In this video, we're going to take a look at an introduction to a topic called the binomial distribution. Now, this topic is actually mainly in A-level maths, but you won't be doing it in maths until next year, unfortunately. So we've got to have a little look at it now, because some questions in further maths sort of rely on your understanding of this topic. Not many, but there is a chance that this could come up. And also it's good practice for next year anyway, so it's good for us to look at it now. Okay, so for a binomial distribution, the notation that we use would look like this. It'd say x follows a binomial. N stands for the number of trials and P stands for the probability. And the key things you're looking out for in a question, if it's a binomial distribution, obviously if it doesn't tell you in the question, because it might not. You've got a constant probability. The event is independent, so from one to the next. So think about it, if you were rolling a dice or tossing a coin, they would be independent events. Like the chance, one event would not affect the next event. If you rolled a 6, it wouldn't affect the chance of getting a 6 on the next one. Main one that you definitely want to be looking out for in terms of like if this comes up in further maths, if they give you a fixed number of trials, it might be a binomial distribution. So it might say like, find the probability that out of 5 throws, you get something, you know, like a 6 3 times. So like 5, 3 times out of 6, more than 4 times out of 7. It's like that fixed number of trials is what essentially means we're going to be looking at a binomial distribution. And two possible outcomes of the thing does happen or the thing does not happen. The best way for us to look at this is if we just try an example. So we said the probability that Manchester United win a football game is 0.3. And given that the games are independent and that they play 8 games, okay, so we're given a probability. We've got a fixed number of trials. So n is equal to 8, p is equal to 0.3. Let's just assume that it's independent. Like in real life, this would not be a binomial distribution. The chance of them winning is not going to be consistently 0.3. It depends who they're playing. It also depends on the game before. Like if they win one game, that would probably increase the chances of them winning the next game because you get into a good run of form, it's confidence. But like we're not going into that. Like we're just going to say, look, it's independent, constant probability 0.3, and then let's see what happens. Okay, so this says find the probability that they don't win a single game. Now you could do this question without you knowing about the binomial distribution, and it also comes from a tree diagram. This, like you could have win, not win. But I mean, I'm not gonna imagine trying to draw that out in the exam. You've got 8 games. You'd have to draw like, 8. It'd be massive, wouldn't it? Like, but what we want to happen is we want them to don't win a game, so not win. That has to happen every single time. They don't win, 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 and so on. Like, so without drawing that out, because you will not have time to do that in the exam, the probability that they don't win is 0.7. And if you want that to happen every game, you could raise it to the power of 8. Okay. But I mean, that's, again, not really a binomial question. Let's try the next bit, because the next bit gives us a bit more of an idea of what's actually going on with the binomial. Okay, so I calculated that out, by the way, you get 0.057, so around about 6% of the time. But now we want to find the probability that they win exactly 4 games. Okay, so this is definitely a binomial. Okay, I would write down the distribution. I'd say, look, I realise this is a binomial. We've got a fixed number of trials. The probability of them winning is 0.3. And from this distribution, we want them to win exactly 4. So if I didn't care at all about any of this context, I could just write down this. I'd say, look, binomial, like the question could have just been written like this without the context, but it'd be far too abstract for us to get a feel for what was going on. But it might just be written like this, in which case there's a binomial, 8 trials, probability 0.3. And we just want to know what's the probability that we get 4 out of the 8, this thing happens 4 times. Now, if you think about this, right, you want them to win 4 games. So the probability that they win is 0.3. You want that to happen 4 times. The probability that if they're winning 4, that means they're also not winning, which is 0.7. 4 times as well. But that is not the answer to this question. Like if you did that, you wouldn't get the marks for this. Like what I've calculated there is the probability of them winning, and then losing. And the key to this is to realise that, like, imagine if we wanted to draw this massive tree diagram out, there would be loads of different ways of ending up with 4 wins and 4 losses. And that's where the binomial comes in. And essentially we can use the notation NCR. You might have seen this in A-level maths. Like, we've also got to multiply that by 8, choose 4, which tells us the number of combinations that this could give us, the number of ways that this could happen. Okay. Now that's all very well and good. Like, but you don't need to show this calculation in the exam. Like, it's nice to have an idea of it, and you look at it a lot more in A-level maths. But like, we can literally just do this on the graphical calculator. Okay. So if we go on to menu stats and go on to distribution, working with the binomial, we get 2 options. Don't press inverse B. We need to be BPD or BCD. And now if it's exactly equal to 4, that's when we'll press F1. So for when it's equal to, go on to BPD. Okay. Data, I've never done this before. It should be set to variable. Yours might be on list if this is a new calculator. So you want data to be set to variable. Don't change that. Just always leave data variable. X in this question. So X is equal to 4. Want the probability of X equaling 4. The number of trials is 8. And the probability of success is 0.3. And if we press execute on that, it just magically spits the answer out. Okay, so the probability of them winning 4 out of the 8 games would be 0.1361. And in statistics, you obviously get a lot of decimals. As a rule of thumb, I always use 4 significant figures. The mark schemes want you to use at least 3, so I'd use 4. Okay. And if you wanted to check if you did that calculation, maybe check, it should give you 0.1361. Okay. The next part, let's see. Okay, the next part says that they win fewer than 3 games. I think the number line's a nice thing to, I don't want to patronise you, but I actually would recommend the number line on these binomial questions, and it will definitely help a lot in maths. Like, if you think about it, there's actually There's actually 9 possible outcomes here, isn't there? They play 8 games. They could not win any. They could win 1, they could win 2, they could win 3, all the way up to winning all 8 out of 8. Okay, so if you did draw your T diagram out, there would only ever be like 9 possible outcomes. Winning 1, 0, all the way up to winning 8. And we want them to, out of these 8 games, you want them to win fewer than 3. So you've got to be careful and think about the wording of the question. Fewer than 3 would be, they could win 0 games, they could win 1 game, or they could win 2 games. Okay, so obviously if you'd drawn this massive tree diagram out, you'd be looking for these scenarios, and it could be 0, 1, or 2, and you could add those up. You could also use the formula if you wanted to, but it would take you a long time. Like if they win, let's say if they won 2, that would be 0.3 squared. So then if they win 2, they would lose 6, and then you'd multiply that by 8 choose 2. So you could work that out. Then you could also work that one out, and you could also work that one out. But we don't need to do that because we can just use the graphical calculator. And the key thing to realise here, though, if you're going to go on to distribution binomial, we're pressing BCD because it's the cumulative. Okay, so if it's less than or equal to, we can press cumulative. Okay, and what the calculator then asks for is lower, upper. Number of trials and probability haven't changed. So the lower would be 0. That's the only thing that's going to change. It's always going to be 0, isn't it? Well, obviously it's less than or equal to. And the upper would be 2. Okay, and if we press that, and then press execute, it spits out the answer 0.55177. 0.5518. Okay, to 4 decimal places. The next one, we're asked for the probability of doing more than 4 games. Okay, if you want them to win more than 4 games, again, think about the number line. You don't need to draw the whole number line out from 0 to 8, but like, when the number's mentioned in the question, like I would do one more, one less, but don't forget, like, there's everywhere from 0 to 8 possible outcomes, and if you want more than 4, that means that they're going to win 5 up to 8. Okay, so what our calculator will do for us, we can say that the lower would be 5 and the upper would be 8. And then that spits out the answer. So between 5 and 8, get 0.0579. Okay, and don't forget what I was saying about significant figures. Like, if you only did that to like 2 decimal places, 3 decimal places, you'd only be getting like 2 significant figures. Like, because it's 0, 0, you want to be using, at least, I would say 4 significant figures in your answers, but at least 3. Okay, just think about that seems like a really small probability, doesn't it? Like, what's that telling us? Like, the chance of them winning is only 0.3. So like, if we want them to win more than 4, like the chance of them winning 5 games, 6 games, 7 games, the chance of them winning 8 games would be 0.3 to the power of 8. That the chance of them winning all 8 games would be tiny. The chance of them winning 7 isn't going to be much better. So like, there's a small chance of these things happening, which is why the actual probability that we get out is quite small as well. Okay, last one, they want them to win between 1 and 4 games. I'm going to change that actually. I'm going to write it as an inequality because it's not clear. I'm going to use the word inclusive. Okay, because it's not clear from that. Is it more than 1 or is it less than 4? Okay, anyway, sorry guys. Between 1 and 4 games. Inclusive. So they could win 1 all the way up to winning 4. And we just need, I'm just going to edit that booklet. You won't even see that mistake anyway. So from 1, lower would be 1, upper would be 4. And that gives us a probability of 0.8844 to 4 dB. Okay, so just a whistle-stop tour on the binomial and how to calculate the probabilities, but you will see a lot more of this in A-level maths, and we also will see it in some of the questions when it links with discrete probability distributions. Okay, thanks guys.